Let me we'll continue the theory of production, what we discussed last time. So we start discussion and we discussed the economic efficiency. So yeah, we discussed the economic efficiency, which has two components: technological efficiency and the allocative efficiency. And also we discussed we have to look at the short run behavior and the long run behavior. Before go further, some advanced discussion production theory, I would like to introduce a very simple differentiation rule that help you even theory of production, consumer theory, and the market structure discussion. So not all the differentiate rule, very simple, and what I need, those things. So we start with the first one, and there are equation like this: y equal 5, which means the constant term, if you write equation form, like x is function of y, and the constant term c may be any number like 5. When you differentiate this kind of constant term, the answer becomes the 0. For instance, if you differentiate y with respect x, then the answer becomes 0. Now for differentiation, the symbol we use usually dy by dx, and also later I use symbol like that. For instance, f x here is mean the first differentiation, or maybe I use the symbol like here, which means the first differentiation. But the rule, what I try to explain, the differentiation of constant term. Second, what we have to understand the equation like that. For example, y equal 3x. Simple equation differentiate so that we can write like fx 3 with the answer. That rule, what important like equation, let's say y equal 3, let's say x power 4, whatever the power, like that, power equation. Now, when you differentiation equation like that, in the general form, I can write to understand x is a function of y is a function of x, and let's say a is a constant term like 3 x n. Now, when you differentiate this with respect x, how answer comes, then take the n here, multiply a x n minus 1. Now, instead of this example, when you differentiate dy or dx with respect x equal 4 times 3 is 12 x 4 minus 1, which means 12 x 3. So that is the, and also we must know how to differentiate the equation like that. The sum of or differences, like for example, 3x power 4, let's say, plus, even the minus also can be, let's say 2x power to 2. Now, the logic is same, only thing is here summation come. When you differentiate, the answer come in dy or dx 3 times 4 is 12, then x 3 plus, here 2 times 2 is 4. So that will be the answer. And also another rule is equation like that, product to, like say 2x power 3 plus 2x, and let's say another equation 3x power 4, like that. So when you differentiate the equation like this, the rule apply. Let's say to understand, I will use this part as a u, this part as a v, then rule apply. Let's say I want to differentiate the y with respect x. U become as it is, and the differentiate v with respect x plus v, right? U dx. Now, this is the general rule apply. Now you can see the answer. You write as it is, 2x power 3 plus 2x. So this part, v x, so that we differentiate, answer is 12 x3. So you have to write here 12 x3 plus, now we write v here, we mean px power 4. The difference is dux here. So when you do that, du with respect x, so become 3 times 2, 6 x2 here plus, then come in cx power plus. So you can simplify if you want, that's the rule apply. Another important we call quotient rule. For example, if you have equation like this, y equal 3x power plus 5x divided by, let's say, 2x. Now, this is what we call the quotient rule. Now, in generalization, like here, let's say the y is a function of x equal, let's say, fx divided by another equation gx. Now, the differentiation rule apply here. When you differentiate h with respect to x, the gx here that the equation become power. So, for example, if you take this one, it's become 2x the power. The numerator fx to write as it is. So whatever the now here 3x power plus 5x, right? And the g that differentiate this respect and write here. Then minus symbol always minus come here. It's coming gs at the equation itself without differentiate. Then fx after differentiate the equation form. Now this particular example is coming like that. dy with respect dx differentiate now this part you write that is 2x power and fx in the what is the our numerator we write which is 3x to power 2 plus 5x. Then this part gs differentiate, when you differentiate this one, this is the gx. So answer become 2. Then the minus that sign here. Then gs, this equation as it is 2x. Then numerator differentiate. When you differentiate the numerator coming 6x plus 5. So that's what we call a quotient rule. Another important rule what I want to introduce, what we call chain rule. Chain rule. The equation like this, let's say y equal something, let's say 3x power to the 4 plus 5x and all bracket 10 power, let's say 22, simple like that. Now this equation we can write before differentiate this part like u entire term. Then how to differentiate? general rule apply like dy over dx equal dy with respect du, then du with respect dx. Now simply what we call chain rule, because this and remain what we get dy over dx. Now the part dy over dx. U is 3x for power 4 plus 5x. Then the du dy over du mean 22 u21. So du over dx mean 12x3 plus 5. Now you can reduce here. The first part 22. Then here comes the u. U mean 3x 4 plus 5x and 21. Then coming to this part, we just write here 12x power 3 plus 5. So that chain rule apply. Not also I don't use, but maybe the macroeconomics you use. And just to introduce rule, differentiation of exponential function, like samya y equal ex. When you differentiate this y with respect x, nothing happen, answer come same like ex. So that is the easiest way. And also, just to say, they differentiate the log function. That is also sometimes you must know y equal, for instance, log x. When you differentiate this one, dy over dx, answer become, since here no any coefficient, become 1 divided by x. So that is also very simple. All right. So those are the things what I want to share, the basic differentiation rule. So far what we apply two variable cases. Now, let's say you have an equation like that y equal is a function of another two variable, for instance, like say 6x power 2 and z power 3. Now, when you differentiate this respect variable like with respect x and z, that's what we call partial differentiation. For that, we use the symbol daba y daba x. When you differentiate with respect, so become, so there we consider the other part has remain constant, and the answer become 12 z 3. That we call daba. That symbol we can write like fx also, because we differentiate with respect fx. Similarly, the y with respect Z also you can do. There we consider whatever the go with X remain constant, then differentiate Z. 6 times 3 is 18. X the power 2 and Z, sorry, power 2. You can write like symbol like that. Differentiation. Now another term also we use this kind of a partial differentiation, we call cross differentiation. For instance, like here, you can differentiate first with respect x, then z. Now our example, when you differentiate with respect x, what we got? 2x, yeah, we got 12x z. So when you cross differentiation, now this one we have to differentiate respect z, then the answer becomes 3 times 12 is 36. Then x remain as it is, we write, and z to the power 2. This is what we call cross differentiation. Now it doesn't matter if you do the reverse version also, first differentiate with respect to z, then x also, no problem. Now we can see how we get the same answer. When you differentiate with respect to z, we got the answer. Previous slide, 18x power z power. So 18 x to power and power 2 z. So now with this we have differentiate. Now we have to differentiate this equation with respect to x. The answer becomes 36 because 2 times 18 is 36. X. Now we said power 2. You can see these two the same, no different. Which means when you difference the cross differentiation x z, no matter order, then z is so, you get the same answer. That rule, what we call the Young rule. Young is the Chinese initially mathematician and become economics, and this rule, the Young rule. So the cross difference. Another thing, when you differentiate an equation, for instance, let's say y equal to x power 4. We can differentiate this in different order. What does mean order? In the first time when you differentiate, let's say with respect x, we call the first order differentiation, which means the answer 8 x 3. We can differentiate again until this power disappears. Second time when you differentiate, answer become 3 times is 24 x 2. If you want, you can differentiate again, third time also, with respect, then answer become 48 x. The last time this differentiated 4 times x. So the answer become 48. You can see different order based on the power you can differentiate. They are one of the important things, whatever the highlight, the first differentiation. Let's say this equation, if you put into the graph, whatever not this shape come in this graph, let's say like this graph came. The first order mean you get the slope of the curve. Whatever the point, you can get that slope of the curve. That is the first order differentiation. That is very important to understand. Yeah, that is partial differentiation. Yeah, and with the help of the differentiation, what we are going to use the microeconomics, we want to identify the optimal point. Optimal mean maximum or minimum point. There, we should need support this differentiation, whether get the maximum or any curve, we get the minimum. For example, we want to find the maximum profit, minimum cost, and maximum utility, whatever different way. Now there, when you differentiate equation, let's say you got an equation, the first differentiation, if it is equal to zero, when usually what we do, we set equal to zero when you differentiate. We get optimal point. That's what we call first order condition or optimization, the first order condition. But still we don't know because this first order differentiation equals zero to mean it can be either maximum point or minimum point because the slope is zero. For instance, let's say you have an equation like that, y equal 3x power 2 plus, let's say, 18x. Now, when you differentiate this equation with respect to x, what you get the answer 6x plus 80. Now, the value this set equal to 0, when you get the value, for instance, 6x 18 minus x equal minus 3, if you put into a graph like that, x, the minus 3, this point, still we don't know where y, you get the minimum or maximum point, optimal point. Still we don't know whether we get the minimum point or maximum point. This first order condition at T, you get the, still we don't know either maximum point or minimum point, or convex or concavity point. So it is. Now, see whether we get the maximum point or minimum point. Really, what we have to do, we have to look at second order condition. That's what we call sufficient condition. The first order condition we call necessary condition. I think you have learned those things in mathematics. Second order condition, what we call sufficient. What happened in second order condition in case of maximum point? You want to get the maximum point. When you differentiate the same equation again, which means the second order differentiation, which means d y differentiate 2 times with respect to x, or we can write like f x x. Yeah. The second differentiation, the value become positive. We can conclude that the particular the optimal point, we get the minimum point, which means something like that. Minimum curve go like that. Convex kind of form. Now, second order differentiation, you get a negative value, which means less than 0. There you get maximum point. Now look at the equation what I gave you right now. This is the first order differentiation. When you differentiate twice this equation, what you get the answer just 6. When you differentiate twice, you get the answer 6. 6 means the positive value, which means this particular equation, you get the minimum point. Minimum point, because the second differentiation positive, which means definitely the equation go like this at t, come to the minimum and go like that. So that, now I'll give a very simple example. Maybe you can try or after the class. This equation y equal minus x1 to the power 2 plus 2x1 minus 2x, second variable is x2 to power 2 plus, here is the minus, it is 16 x. Now this equation has three variable with one x1, the other one x2, here the x2. And you find the optimal value at the optimal point, how much the value for the x1 and x2, then whether the x1 get the maximum point or minimum point, similar to x2 also. For that, what we have to do, the differentiate this equation with respect x1. When you do, you get minus 2x1 plus here 2. Now the optimal point, like we said, the slope becomes 0. So then the answer, what you get, the x1 equal 1. So this at x1 get the optimal point. We don't know the minimum or maximum. Now, to find out that we have to differentiate this one twice. You have to differentiate this twice. When you differentiate again with respect x1 2 times, you get definitely here answer minus, which means less than 0. So definitely the equation go with x1 like that to get the maximum point. Similarly, you can do same exercise with the x2 also. Now, when you differentiate with respect x2 the first time, first differentiation, answer become minus 4x here 2 4, yeah. Then the minus 16. So when you set equal to 0, get with optimal point. So what the answer what we get x2 equal minus, in this case, x2 equal minus 4. So at the minus, sorry, at minus 4, get another optimal point with respect x2. When you differentiate twice with respect x2, you can see whether really get the maximum point or concave or minimum point. When you differentiate twice here, you get the answer minus 4. The minus 4. That also, in this particular example, you get the maximum point, not the minimum point. Because the minus points mean less than 0. So negative, let's get the maximum point. I hope you got this point. Yeah. Now, if we go back, yeah, the things what we discussed last time, and we discussed the short run average production curve, the behavior shape also we discussed, and the short run, the marginal production curves also behavior we discussed. So last time we already discussed those. Now here, very important thing also we discussed last time. Yeah, identify some stages. There are boundaries we identify. Now with the help of differentiation, for instance, if you are given the production function, let's say 6L power T plus 2 power 2. With this equation, you should be able to find the boundaries here and these 3 stages. What we discussed these 3 stages is stage 1, stage 2, and stage 3. That's the last point what we discussed. Now here look at the boundaries of stage 2 and stage 3 here, the point B, there you can see the marginal product becomes zero. Now, what is the marginal product? Mean when you differentiate this one with respect L, Q respect L, we get marginal product. In this example, let's say 318 L power plus OL. That is the marginal product. Now, when you set equal to this marginal product equal to 0, then you can find the value for L. In this case, of course, we don't get a very good value. What we get is even the negative value. 4 divide 18, which means minus 2 divided by 9. So the minus can't be, because I just gave a number. That is this point you can identify how many number of tables. I'll give another example after that. Second boundary here, there you can see marginal product equal average product. Or this is the point we get the marginal product come to the maximum point. So they are the maximum point. If you find the maximum point of average product, you can get the answer. Now, from here, you can get the average product divided by L. So then you can find those value and things easily. I'm going to give you a very simple example. Yeah. You can try. Let's say the production function is 60 k to the power 2 L power 2 plus k power 3 L power 3. Now, since in the short run, we just assume k equal to, now you can find the short run production function. And then here you find the marginal product of labor and the average product of labor. Then you can find these 3 stages, the boundaries of 3 stages, like point A and point B. I'll give you maybe 2 minutes, you can try. With that, you can find the labors at the boundary first and the second boundary, and these 3 stages, clearly you can find. after the lecture you can try. And let's say you found the boundaries here like 10, here 20. Now, the last time what we discussed, in the short run, the producers take the decision, stage 2, producers take the decision in stage 2. Why not stage 3? Because the stage 3, you can see the marginal product is negative. So no producer recruit labor, so any inputs, its marginal value, marginal product is negative. Marginal product means if you additional, when you recruit someone, it contribute to the total become negative and the total goes down. So the producer, they don't do, except maybe the public sector, because they don't look at that way. And why not the prestige? You can see the prestige always marginal product is greater than the average product, which means when you recruit in inputs, the stage as a producer, you get advantage and your profitability increase because the marginal additional value given by new, let's say the labor, new employee, is add to the total product. The total product increase in rate. So with that, producer continue recruiting until 10. So after 10, if the producers decide to produce, recruit labor, which means exact amount between 10 and 20. We can find exactly how many number of labors. For that, we need the market price, we need the value, and the wage rate, the value we need, and also other input prices, in this case, the capital, those values. In this, we can identify. What happened again, stage one, if you look at the economics point of view, fixed capital, let's say a machine, is underutilized. Now let's kind of like this. If you have a public bus, you are the public bus owner, it's like something you have 3 buses, but only you have 1 driver. So in the underutilized state, the opposite. The opposite. You have uh, 2 buses, but you have like 4 drivers kind of situation. Overutilized. What the producers can optimize their production is stage with specialization and teamwork. That is what happened. Stage 2. We can look at this with understanding of elasticity. Let's say the labor elasticity. How to find the labor elasticity? Dabba Q divided by Dabba L over Q. So that's how labor output elasticity. Now look at the production curves what we draw. First I draw total production. Then I'll draw marginal and average production curve. Like we discussed the marginal production goes like that. And average product curve goes like this. Now it can go back this elasticity and say Now there the first part here, I think familiar to you, that is the marginal product of labor. If you select the capital elasticity, you can say the marginal product of capital. The second part, this part, the second part is not familiar, but the second part you might remember Q divided by L, that is the average product. In this way, the second part becomes 1 divided by the average product of labor. So simply what you get, the labor output elasticity is marginal product divided by the average product. Marginal product divided by the average product. Now look at the elasticity. Now look at how much elasticity this point. Point A. The marginal product is 0, when the elasticity also becomes that 0.0. You can see how much elasticity this point B, the marginal product equal average product. So you can see the elasticity here become 1 with MP equal AP. Now here the stage 3 now, look at the elasticity, the marginal product is negative. So the elasticity become, labor elasticity become negative, which that happened this third stage. Look at the first stage, the marginal product is higher than average product. So according to this formula, then the elasticity must be greater than 1. Greater than 1. So automatically you get the stage 2 in between 1 and 2. 1 and elasticity between 1 and 0, greater than 0, less than 1. Now go back to the decision stages. Look at the third stage, the elasticity is negative, which means the elasticity negative mean if you 1% add labor, or let's say 1% increase your labor, result in the negative elasticity mean decrease output. Exactly, you can say the stage here, output decrease, elasticity negative. Stage 1, elasticity is greater than 1, which means 1%, for instance, increased labor or whatever the input, output increase greater than 1%. Output increasing rate. So in that way, the producers get more benefit and more profit, and they will continue. So stage second is the option in that case, in between and indifference, and they are make the short-term decision. So that's what happened in the short term. I think you understood. Now, when you come to the long run, that also we have to understand the behavior of producers, how long run they take the decision. The first, before you understand the decision making, you have to understand the two concepts. One is ISO cost curve, the ISO quant curve or ISO product curve. ISO product curve. The other one, ISO cost curve. So these two concepts you must understand before understand the long run decision. Now, ISO quant curve, quite kind of a curve, share the second stage of this behavior, you can see the second is apply diminishing marginal return, negative slope of the marginal product. Here we develop a curve called isoproduct curve. Let's say isoproduct means alone any point, if you take the production is equal, same amount, in this case, ET. Either you take the decision to recruit labor and capital point A, or B, or C, it doesn't matter. Same amount of production, and it doesn't matter whatever point you are technologically efficient as a producer. But it doesn't mean that economically efficient. For that, we have to go allocation. So that is the isoquant curve. Slope of the isoquant curve, also a very important concept that we call marginal rate technical substitution, MRTS. How do you find MRTS? It's very easy. You divide marginal product of labor by the marginal product of capital. That's how you find slope of this market. Cost curve is related to budget. Let's say your firms, you have particular amount of budget each week. Capture that, we develop a curve called cost curve. It's a straight line like that. C equal W L, that is the labor budget, and other input. In this case, we take capital. This is the one. So we can here rewrite the equation K equal C divided by R minus W divided by R L. There you see we got the slope here, negative slope. That is the slope of the here WR. Now, point here, this isocost curve produces whatever point they decide to expand. Let's say X point, Y point, or Z point, which means the expand mean by capital and labor. The producers are allocated to efficient. Now see, allocate to efficient. Inside produce, for example, let's say this budget is $100. If the producer or manager expend $100 here, he is not allocated to efficient because he buy that happen exactly the public sector. Let's say 2 amount of capital and 6 amount of labor. But you can see the maximum optimal level, he can buy more labors and increase the production, for example. Or maybe he can buy more capital, or both, buy more and improve. So in that way, the allocated efficiency only the line. Now you can see cost curve side, we get allocated efficiency. Isoquant side, technical efficiency. What we do, the economics, we merge these two and try get, so you get the cost curve allocated efficiency, product curve, technological efficiency. So this point both satisfy, which means producers reach economically efficient point. So they are the both allocated efficiency as well as technological efficiency you get and you satisfy. Any other point, we don't get the economically efficient point. Now, as a Typically, producers have reached this one the two ways, maybe no need to do both way. One way is the producers try to minimize cost. We call cost minimization. Given amount of output. Given amount of output. Or maybe producer try different way. They try, you may have heard that, try to maximize output. Maximization. Try to objective is maximize output. But the constraint, they are given budget. Given budget. Budget is given, like here. So in both way, the producers reach to this point. They, now that what we call duality, that point you see the satisfy slope of the both, which means the W R over, that is the input price ratio equal to MR PS. So this is the best condition producer reach to economic efficiency, optimization, or minimize cost or maximize output. So this first condition must be satisfied. This condition. With this condition, we can find how many number of labors recruit, how many number of capital recruit optimal point. So that the thing producers right. For that, the producers may use the minimization cost or maximization of output. Yeah, you can reach. Wow. So this point, I'll stop today, and I will continue next week how you find this maximum optimal amount of labor and capital, and then we'll continue the cost function, and most probably next week we will finish the way of production and theory of costing. So we want to do the market structure, and you can visit the YouTube also here, even the tomorrow lecture also. No need to record that already there. So anytime you can watch this lecture in the YouTube. Okay, thank you very much. If you have any questions, so we can have some time. Otherwise, we can leave the meeting. So your assignment deadline, yeah. Once
Thank you, sir.
Okay, thank you very much. Thanks. Bye bye.
Okay, bye.